Hello everyone. So here we are talking about phase graphs and phase diagrams. Today your topic is phase diagrams. Your goal: I can label and read phase diagrams. So the first thing we are going to talk about is phase graphs. Now remember, in your notes section, I know I'm always repeating myself. If it's red, you need to highlight it, type it out, and then highlight it in your notes. If you're not sure how to do that, in the very first video where we talk about what is chemistry, I show you how to highlight words. Okay, and then everything else that is just underlined, you just need to type that out in your notes as well. Okay, so phase graph usually show time and temperature. Okay, here's the important part. The line on the graph shows the substance's heat and time increasing. Where the line flattens shows where there is a phase change. Where the line increases or decreases shows the phase. So here's an example. You have a chart that as it's going up, it is a phase, and the first phase is always a solid. So think of water. When it's at its coldest or when the temperature is at its lowest, it is a solid. Okay, whenever it flattens, that is when it's changing from a solid to a liquid. Now, if it's going from a solid to a liquid, that would be melting. If it's going from a liquid to a solid or the opposite way, that would be freezing. Okay. All right, so now it starts going back up again. Well, that is when it's a liquid. Now, when it's flat, that's the phase changes. So now it's going from a liquid to a gas, so that would be when it either evaporates or boils. Either word will work. Now, the opposite of that is condensation or condensing. So as the heat goes up, it goes solid, and then it changes, and then a liquid, and then it changes, and then a gas. So that is how you read a phase graph. So here you have this chart. I'm going to draw this on the piece of paper. So on the side, you have temperature as it goes up. And on the bottom, you have time. So it goes up, flattens, up, flattens, up. We have a mark here for A, B, C, D, E, F. All right, so here we're going to label A. When it's first going up, it's that first phase. So think of water. When it is the coolest, what phase is it in? It's a solid. B, that's where it's changing. So there's two options for this. What is it called when something changes from a solid to a liquid? It is melting. And then what's the opposite of melting? Freezing. All right, so now we have C. That's another phase. It goes from solid, and then if a solid melts, it turns into a liquid. I know I said label to F, but I actually mean E. Okay, so D, that is at this phase change. So if something goes from a liquid to a gas, that would be evaporation. And the opposite of evaporation is condensation. And then E is that last phase, which would be gas, which I had up here as well. So if you wanted to keep that, you could as gas. All right, so those are your phase graphs. All right, so now we're going to go to something a little more complex. It's called phase diagrams. So phase diagrams, make sure you type that out and then highlight those two words. And then write the definition after that. A more specific chart that shows what phase a substance is, a specific time and pressure. So this is a little more detailed. A phase diagram, you don't have to type this out, but a phase diagram shows the equilibria pressure-temperature relationship among different phases of a given substance. All right, so here you have 3 lines. You have your solid group over here. You have your liquid group in the middle, and you have your green gas at the bottom. All right, so where these lines are, like right here in between solid and gas, that is where you see your phase changes. Where the arrows are pointing, that's the type of phase. So for example, in between solid and liquid, if a solid goes to a liquid, it melts. A liquid to a solid would be freezing. Okay, if it's in between a liquid and a gas, you have your vaporization, also known as evaporation, going from a liquid to a gas, and then condensation, going from a gas to a liquid. And then the gas and the solid, these are 2 words that you may not heard before. If something goes from a solid to a gas, that is called sublimation. And then something goes from a gas to a solid, skipping the liquid phase, that's called deposition. Okay, where all 3 lines meet is called a triple point. Okay, so this is where solids, liquids, and gases, if it's at that exact temperature and at that exact pressure, you will see all 3 phases. And then there's a dot up here, something called a critical point. So here is a specific example of a phase diagram for water and for carbon dioxide. And I'm going to show you how to read these. All right, so on the side, you will see we have pressure. Keep clicking. You have your pressure right here. And then at the bottom, you have your temperature. Let's move on to the next one. So here, what phase would water be at 50 degrees Celsius and 2 atm? So you have your pressure and you have your temperature. And this is your water. And then CO2 is your carbon dioxide. So we need to look at this one for water. So first, find your temperature, 50 degrees Celsius. Well, 50 is in between 0 and 100, so it'll be about right here. And then 2 atm. So we go up to 2 atm, which would be around here. It's in the blue, so that means it would be a liquid right here. Number 2, what about carbon dioxide? So it's wanting 50, to look at number 1, 50 degrees Celsius. Well, that's way up here. And then 2 atm would be up here. So just because this is not on the chart does not mean we can guess what phase it is. Okay, if this just kept going and moved over, we would still be in the gas phase. So that would be the answer for number 2. Okay, number 3, what phase would water be at 100 degrees Celsius and 1 atm? Okay, here it is on the line in between a gas and a liquid. So there's 2 options for this. It could either be changing from a liquid to a gas, which would be called evaporation, or it could be changing from a gas to a liquid, or that would be condensation. I would take either of those answers as an correct answer.